All right, what we're going to do in this lesson, this is 7.4, is we're going to talk about general transformations of all of the parent functions that we're going to talk about in Algebra 2. And when I talk about parent function, a parent function is the most simple form. So it's the most simplistic form that you're going to have of everything. So for example, if I have x squared, I know that this is going to be a parabola that's going to be shaped up because this is positive, and my most simple form of my parabola is going to be something that looks like this. And it's going to look like this. All right, that's my parent function, most simple. I don't shift left or right, I don't shift up or down, my slope is 1. All right, same thing with my absolute value function. I know that this is going to be a very solid v. I start at 0, 0, and I have a slope of 1, and then I have a slope of 1 in this direction. So this is my parent function. All right, so this is my line. This is just my line. Y equals x is a line, and I know that there's no shifting. I have no intercept listed, so it's here with a slope of 1, except for I know I can go negative. So here is my line. Okay, so we're going to introduce 3 more functions here, and we're going to talk about these 3 functions. And I'm going to help you sketch the graph of each of the functions by putting in this table. So we know what the square root, how to calculate a square root. So if I have the square root of 0, because this says when x equals 0, well, the square root of 0 is 0. And then this says, what is the square root of 1? Well, the square root of 1 is 1. And then we're going to jump here to the square root of 4. So the square root of 4 is 2. Now, the reason why we did this is because if this was the square root of 2 or the square root of 3, that's not a perfect square, so I don't have a nice, pretty number. All right? And then I have the square root of negative 1. And we know that the square root of negative 1 is I, but I cannot be graphed on our graph. So because of this, this does not exist. I cannot have a negative on my graph. So now if I'm going to go plot these points, I have a point here at 0, 0, and I have a point here at 1, and I have a point here at 4, 2. And I have no negative values, can't have a negative square root. So this function is going to look like this. So this is my parent function. This is important to see this. This is the parent function for these different graphs. So just like these are the parent functions, the most simplistic, this is my most simplistic square root function. All right, so now let's do this one. So this one, obviously we know this is the square root. This one is going to be the cubic function. So what I have here is 0 cubed. Well, 0 times 0 times 0 is still 0. And then I have 1 cubed, which is 1. And now I have negative 1 cubed. Now this is a value. I have negative 1 times negative 1 times negative 1. So because this is negative, this is going to stay negative 1. And then this point is going to be 2 cubed. And 2 cubed is 8. So if I go plot these points now, I have 0, 0. And I have 1, 1. And I have negative 1, negative 1. And then I have this point at 2, 8. So it's clear up here. It's off my graph. And if I put negative 2 in, I would have negative 2, 8. And it would be clear down here off my graph. So what the cubic function looks like is it looks something like this. It evens out and then it goes back steep again. So we have this little kind of flat cross as it goes through here. This is not a straight line. It's a little bit curvy as you curve in between these points. Okay? And then we have this function 1 over x. Now this one's tricky. So if I put this value of 0 in, I would have 1 over 0. And if you remember, this means no, we can't do this. So this value does not exist. I cannot have a 0 in the denominator. This next one, if I have 1 over 1/2, if you remember what we did when we were solving rational functions, is we said turn this into old school division. So 1 divided by 1/2 is the same as 1 times 2, and 1 times 2 is 2. When I put 1 in that denominator, I have 1 divided by 1, which is 1. And if I have 4 in that denominator, I have 1 divided by 4, which is 1/4. So these numbers look pretty bad here. So let's see what this looks like. So when I have this value of 0, I don't even have a point here. It doesn't exist. I can't have a point at 0. And so what we do is we say, okay, because I can't have a point at 0, I'm going to put a asymptote here and an asymptote here. So these are asymptotes. And I have it in my parent function. This is when I have 1 over x. I have an asymptote at x equals 0, and I have an asymptote at y equals 0. All right. Now this says at 1/2, I have a point of 2. Well, here's 1/2, and my point of 2 is here. So it's in between 0 and 1. I have this point at 1, 1. And if I have a point at 4, 1, 2, 3, 4, I have a point of 1/4. So I have a point that's clear down here. So what happens is my graph looks like this. It approaches this asymptote, and it approaches this asymptote, and it's kind of shaped like this. Now, here's the thing. This table's not big enough, but whatever happens in this quadrant is modeled down here in this quadrant. So I end up having something that looks like this. So this is my parent function, and I have to have this part, and I have to have this part. So the parent function of 1 over x has 2 asymptotes and 2 parts. Okay, let's keep going. All right, this says try these by yourself. So these are just your parent functions. So go ahead and try to sketch these without flipping your paper over. Okay, go ahead and pause the video and then come back. All right, so we're going to move on. So when we have a parent function, we have a transformation. And transformation, all this means is change. So we are going to change from the parent function. So we're changing from the original. Now, this is not new. The format is a little bit new, but this is not new. What this is saying is we have some function, and it might be a quadratic function. It might be a cubic function. It might be, I didn't write this down, but this is a rational function. It might be any of those. And that says whatever we have added or subtracted at the end. So this means at the end, then this is going to be up or down. If it's positive, we're going up. If it's negative, we're going down. Now this is inside the function. And think of this as something, and here I'll give you an example. This would be y equals x squared plus 3. This plus 3 is my plus or minus c. Now we know they have nothing here, so this just tells me that I move my quadratic up 3. This would be if I had something that looked like this. Let me finish this. So it's going to go right or left. So if this is my function now, x minus 2 squared, this is my plus or minus c that's on the inside. And it's opposite of what we think. So here we're going to move to the right when it's negative, and here we're going to move to the left when it's positive. So absolutely nothing new. What's new is now we're going to throw all of the different functions. So we'll start with 2 that we haven't done. So we're going to start with the square root function. So we know that our general square root function looks like this. That's my general square root function. So now all that's happening is I'm moving up 2. So if I start at 0, 0 on my parent function, I'm going to move up 2, and my next point is going to be this point. This tells me now that I'm going to move to the right by 3. This is inside my function, right? This is outside my function, so it's important to be able to see the difference. So this one, I'm going to move right by 3. I go up 1, and my curve looks like this, right? With this guy, I've got it inside my function and outside my function. So I'm going to go left by 2 and down by 3. So my starting point, left by 2, down by 3, and then I go up 1, and my function still looks like this. So what you'll notice is if I'm going up, if I'm going left or right, or if I'm doing both, the shape of my function is never going to change. It's going to look like a square root. Now, what could potentially change is if I make it negative. If I put a negative out here, we're going to get to this in just a minute, then it's going to shift a little, or it's going to change the direction, but the general shape is going to still be this one-sided arrow. All right? So we know that this is now cubic, and my cubic function has these 3 points right here, and so I know that it's going to look like that. That's my parent function. So this just says my parent function moves down 2 before it starts. So if I move down 2, I still have my 2 points right here. So now my parent function is going to look like this. Super important you don't make that look like a line. All right, again, same thing, opposite of what we want because it's inside the parentheses. Now let me go back and look at this. Here is just x cubed. This is why I stayed on this y-axis of 0. I didn't move left, I didn't move right, I only moved down. This is inside. It's important to see the difference between D and E. So this tells me that I move left 1, but I still have these 2 points. Now here my starting point is going to be 2, 1. I moved to the right by 2, and I moved up 1. So 2, 1. Again, I add those 2 points on both sides. And this is what it looks like. So what's important? It's important that you go back to your parent function and you know that this point and this point are gotta haves. And this point and this point and this point are gotta haves. And over here, my gotta haves are going to be these 2 points. They're the ones that are going to be right outside of our asymptotes. All right? Okay, let's keep going. We've got our absolute value. We've done this already, but as you see, I'm gonna mix them all up here. So here my vertex becomes 2, negative 3. So 2, negative 3. I know that my parent function here is a v, so these are my 2 points. This is going to be a quadratic, negative 2, 1. I know I go up 1 on both of these, and it's going to be a definite v. Or sorry, definite u. This is a v. This is a u. And what is this one? This one's linear. So this is mx plus b. So I start at negative 3, and I'm going to have a slope of 1. Okay, let's get into these. So here are my rational functions. These are harder. So I'm going to go a lot slower on this. If you remember my parent function, I had an asymptote here, and I had an asymptote here, and I have a point here at 1, 1, and a point here at negative 1, negative 1, and this is what my graph looks like. Now, all of these parts are important. You've got to have the 2 asymptotes, and you've got to have the point that is right on both sides, close to where those 2 asymptotes cross. So here's what this looks like. This value here is going to be my vertical asymptote. Well, my vertical asymptote, remember vertical is up and down. There's no other value here. It's just an x. So because of that, that means my vertical asymptote is going to stay at 0. Kind of a look ahead. Here we have a number in the bottom. My vertical asymptote is no longer going to be at 0. It's going to move. It's going to move here too, right? This part is my horizontal asymptote. And remember, horizontal asymptote is this way. Horizontal is a line that goes this way. So this tells me that my new horizontal asymptote, here it was at 0. My new horizontal asymptote happens down here at negative 2. So this is 0. Because there's nothing connected to the x. This is negative 2 because over here this negative 2 is on the outside. It affects my y value, so it shifts down. Now for my rational function, here's where my 2 asymptotes cross. So I go to the closest point here and the closest point here. So this is where my xy's cross, and then it's going to approach both of these like this. All right, Here, this again is my VA. And now my VA happens at x equals 1. So just like with everything else, when it's attached to, well, not the linear functions, but everything else, when it's attached to the x, this is opposite of what we think. So we're going to move to the right 2. We're going to move to the left 2. Here, my VA happens at positive 1. So I have this vertical asymptote here at 1. This one is my horizontal asymptote. So the horizontal asymptote happens now at positive 1. And then if I go to this intersection, I have a point here, and my other point is going to be here. And this is what my graph looks like. Now, if you notice, the way I have this drawn is I'm going to do this over here. I am not doing this. I'm not doing this. It's not two right angles, right? They are curved functions that approach this asymptote and approach this asymptote, and there's a curve in these two lines. So don't make these look like right angles, because that's not what's happening, okay? All right, last one. So VA happens at negative 1 and negative 1. So this is negative 1 because it's opposite. This is negative 1 because it's exactly what we want. And then here are my 2 points. And so my graph looks like this. Okay, these are just lines. So this shouldn't need a lot of explanation, but this is mx plus b. So when I have no b, I start at 0, 0, and I have a slope of 1. And so I have a line that looks like this. This is my parent function. There's nothing fancy happening with that line. This tells me that my intercept is negative 2. I still have a slope of 1, so my line looks like this. And then my last one, intercept of negative 1, and my slope is this time 2, so up 2 over 1, up 2 over 1, and I can go this direction, down 2 over 1. All right, let's keep going. So the next page of our notes, we're going to add one more thing. So we already said that this shifts the graph up or down. That's when I have this plus c on the end. And when it's in the inside of my function, it means we're going left or right. So up is going to be positive, down is going to be negative. When my graph is shifting to the left, it's going to be positive, and when it's shifting to the right, it's going to be negative. So opposite of what we think. Now, what this part of my graph says is this is going to be a reflection over the x-axis. Now, what this means in more simple terms is that my y values change. So if I had a y value, that was positive, so positive y becomes negative y, or negative y becomes positive y. So my y values are going to change. They're just going to go from positive to negative or negative to positive. Okay? And this a is going to be my slope. It's going to be whether I'm going, and I put slope in quotations because if I had something that looked like this, 3 times the absolute value of x, this is a literal slope. If I had something that looked like this, 3 equals x squared, this is only a first point slope. So it's important to know, based on the shape of your curve, what that 3 would mean. All right? So let's talk about this one. So now what happens is I'm going to start my graph. I'm going to put my first point of my graph in the normal place. All right? So this normal place that I would have here would be if my graph started at 0, 0, right? But now I'm going to shift up 2. So here would be my first point. Now that's not going to change, right? That's not going to change. But what has to happen here is what happens to the shape of my graph. So the shape of my graph is now going to go down instead of up. So I'm going to just sketch a parent function. So my parent function here would look like this. This is my parent function, which is the square root of x, plus 2 actually, because it would be shifted up. So now I'm going to take this value that I would have here, And because it's going down, remember my y values are going negative, it's going to be down here. So this graph actually is shaped this direction. It doesn't go up, it comes down. All right. So with this one, I have to find my starting point first. So my starting point of this graph is going to be at 3, 0. Now this tells me my slope. My slope is my first point. So instead of going up 1 like I do in my parent function, now I'm going to go up 2. So this is the next point of my graph. So it still has that same shape, but now that shape is going to be stretched out a little bit. All right, so we're going to start with this. We need to find where my graph starts. So my graph is going to go left by 2 and down by 3. So here's my starting point of my graph. Now, like I showed you over here, my parent function would normally look like this, but now my parent function is going to go down. So this is my next starting point. So it looks like that. All right, let's look at a couple of cubic functions here. So I know that this tells me it's cubic, so my cubic function is going to look like this. So my new starting point for my cubic function is going to be at 2, 1. 2, 1. That's my starting point of this. Now, here, this gets a little bit tricky because what happens is, if you remember, this tells us that our y values change. So I'm going to sketch our parent function here. So this blue is my parent function. If I had this same shift, so this would be what my function would look like if it was just y equals x minus 2 cubed plus 1. That's what that would look like. But what I'm going to do now is I'm going to take this and I'm going to apply this negative 1/2. So what I have with this is, because this is negative, my values are going to switch. So this value here is going to be down here. It's going to be negative, and any negative values are going to be up here. So my shape of this, when it's going to be negative, is going to switch. And then this tells me I'm not going to go by 1 anymore like I do on my parent function. Here, this tells me this is a 1. So this is why I went from here to here. I went by 1. This tells me I'm going to go by 1/2. So I have two things happening. My next point is going to be here and here. I'm not going up 1, I'm going 1/2, and I'm going 1/2 in this direction. Now, the reason why is my shape is going to look like this now. So this is my new graph. That's this one. So let me repeat this again. So I go 1/2. So that's why this point here is at 1/2. It's not all the way down here. So my parent function, it's linear. This is not linear because this is 1/2. And this tells me that the direction changes. So instead of opening this way, this value flips and this value flips. So that's why it's shaped this way. So one thing to remember is all cubic functions that are negative are going to shape this direction, and the parent function, just as a repeat, is going to shape this direction. So here's my parent function, which is positive x cubed, and this is my cubic function that is negative x cubed. So positive opens this way, negative opens this way. So that's a little bit tricky. All right, so same thing here. We're going to start with what we know, and then we're going to go back and address this negative. So I know that I have a vertical asymptote at -2, and I have a horizontal asymptote at 1. Okay, now my parent function would tell me that I have a point here and I have a point here. That's what my parent function would tell me. But this is saying it's the opposite. So if this is where my parent function should be, in this quadrant, now it's flipping and it's going to be in this quadrant. If my parent function was here, now it's here. So this is what my function looks like when it's negative. So let me go over here and say my parent function is going to be in quadrants 1 and 3. and this is going to be a negative inverse function. A negative inverse function is going to be in quadrants 2 and 4. All right. I know that this is new. This is just one more thing that you have to remember with these two. With a square root function, all you're doing is you're just shifting it down. But when the negative is out here on a cubic and a quadratic or in a rational, it looks a little different. The locations of your points change. Okay, we're going to do this last little bit here, which is writing the equation. So first thing I know is that this is a cubic function. So based on the shape, I know it's cubic. I also know that my 3 points are fully aligned at the cross marks here. So the only thing I need is this point here, and I'm going to call this my vertex because it's really kind of where it shifts. It flattens out a little bit, and that happens at 0, -2. So my function here is just going to be x cubed because I'm not moving to the left or the right, -2. All right, so hopefully you identify this as the square root function. So my square root function starts here at 0, 0 and goes this direction, right? So this is going to go 1, 2, 3. So I'm going to have y equals the square root of x plus 3. My starting point, I moved to the left by 3, and then I went down by 2. Super important that you have a break here as you write this. This is the end of your square root, and then so this tells you your left, right, and this tells you your up, down. Okay, last two. I see this. I know that this is a rational function, 1 over x. So the first thing I need to do is see where my new vertical asymptote is. That's this one, verticals up and down, and that happens when x equals -2. Now remember, this is on the inside of my function, so it's opposite of what I think. So it's going to become x plus 2. Vertical is over here, -2, so I say plus 2. Now, I also went down 1, 2, 3, so this is going to be -3. Now, the other thing that I didn't check on this, and let me go back and talk about this. I did on the first one, but not here. Because I started here and my next point is up 1, this value here is just a 1, right? So I don't write it. You could write it, I guess, but you don't need it. It's the same thing here because this point starts at 1 up and this point is 1 down from where my asymptotes cross. There's no value here. It's like a 1, which you wouldn't write that. You would just leave it the way I had it. All right? So last one. I know that this is a V shape, so this is going to be my absolute value function. And my vertex here happens at 2, 0. So I end up with y equals the absolute value of x minus 2. Right? Nothing on the end because I'm not shifting up or down anything. And then I'm going to check. Here's my vertex. I went up in both cases. So my slope here is 1. So I'm not even going to make a line there. I know that that's just 1. All right? Lots of things happening in here. So come see me if you've got problems.